Today I'm asking a simple question. What does this little symbol means? And I know I'm talking to people who have a certain understanding or at least a certain appetite for mathematics, so the answer should be pretty obvious. The equality symbol means that both things on either side are in fact the same, whether it be the same value, the same coordinates, or the same formula and so on. Okay, so if I write this, what's the meaning? This may seem like a silly question and you're probably already thinking, well, it depends on the context. And I agree, that's actually what I want to talk about today. Because it's an important point, especially for younger audiences. We are told many things in math and often we simplify the context of a statement to make it less boring. One of the simplest examples of that is the rule of triangles. You've probably learned that in a triangle, the sum of all angles is equal to 180 degrees. This statement is incomplete. Let's say you're on the North Pole. I don't know why you are here, but it sure does make this video cooler. And you head straight south until you hit the equator. Then you turn right and go around a quarter of the world. Then you turn right again and go back to the North Pole. Most people would agree that you've drawn a triangle, and actually, mathematics is kinda okay with that. If you're precise, it's a triangle on a curved surface. And we can also discuss angles, because to make your journey, you've turned at a right angle twice. And since you go back to your original position after a quarter of a complete turn, it's pretty clear that this angle should also be a right angle. So we have a triangle with 3 right angles, so the sum of all 3 is equal to 270. This is not a trick. There's no real question of angles being badly defined or those angles not actually being 90 degrees, and we could find other examples with other values. The problem here is from our property. Yes, the sum of angles in a triangle is equal to 180 degrees if that triangle is on a flat surface. Context matters. To go back to our original problem, from what I see, there could be 3 meanings to this equality. First, as a definition, this equality is saying that the function f is defined as a constant function of value 2. Second, as a comparison, let's say the function f was previously defined as being f of x equal x plus 2 minus x. Then the affirmation could be made that this function is actually just the constant function of value 2, since the x cancel one another. Or third, as an equation, find all the value of x, such as f of x equals 2, with f being a previously defined function. This is actually the 3 main meanings of this symbol. It can be used as a definition, as a comparison, be it an affirmation or a question, and an equation. This is not scientific terminology and there doesn't seem to be a consensus on that end, but I'm sure if you look at it with your own experience, you can find some examples of such differences in the meaning of that symbol. For example, one could argue that comparison and equation are one and the same, because an equation is just a way of making a comparison given a certain value of x that we need to find. It can also be a definition. X is defined as the unknown of this equation, which means that even in the same context, this little symbol can have many different interpretations, all as equally valid. And worst, or better if you're a bit like me and like overthinking, if we say that comparison and equation are the same, it means that even with the same weight attached to it, this symbol can actually mean 2 different things. This point is important, I think, because in my teaching, I found students that in the middle of a test asked me if f was a constant function or if it was the same f as previously defined. The context was set in the test, as usual, but it had never appeared to them that this could have different meanings, even though we did exercises on it. Students. To further on that point, a lot of mathematicians seems to have, consciously or not, find all of those interpretations a bit confusing and came up with another notation. For function, we have the classical notation that sums up pretty much everything you would like to know about a function, or sometimes the literal arrow alone. People who watches my other French videos know that I like it, for that reason. But for larger purposes, we have this little symbol, an equal sign with colons in front. This is broadly used in mathematics books to mean definition, no more ambiguity. And as a bonus, when you see the equal sign alone in the same book, you know it's probably not a sign of definition, which can, sometimes, help clarify things a bit. So yeah, that's just what I wanted to point out. Context alone is oftentimes enough to understand those things subconsciously, but sometimes it's nice to stop for a minute and see what our mind does, so that we may be prepared when meeting someone that doesn't have those reflexes. Understanding what is not understood by others is the first step of being a good teacher. Anyway, that's it. I usually close on a French pun, but it can't really be translated. Oh well, I guess this is the aftermath of doing a video in English. Thank you for watching.